Welcome to this channel. In this video, we are going to discuss 20 question objective, which is related with the quiz in the CHEMZOOM, and it is involved chapter 1 and chapter 2. Question number 1. How many electrons are there in Mercury plus? So from here, we know that this is the proton number. So there is 80 protons, and then we need to find out how many electrons are there. Then here let's see there is a positive charge, means that proton will be more than electron for 1. So that's why it means that electron have 79. So this is the answer for this question. Question number 2. All the following statements are true except, means that we are going to look for the false statement. So nucleus is positively charged, correct? Because inside the nucleus there is proton and neutron. So neutron is neutral, proton is positively charged. Proton number indicates the number of protons in an atom, also correct. Isotopes are atoms of the same element but with the different neutron numbers, correct? Okay, so this is only part of the definition of isotope. Besides from different neutron number, at the same time they are going to have same proton number. So means that the last option is the answer. Neutron number is the total electron and proton in an atom. So electron is wrong. The correct answer supposedly is neutrons. Question number 3. How many hydrogen atoms are there in 55.2 grams of ammonium sulfide? So basically, we need to know the relationship between mass, number of mole, and also number of particles. So as we know, when you are given the mass, you are able to determine the number of mole by divide the molar mass. So when you use the mass of ammonium sulfide, divide by the molar mass of ammonium sulfide, you will get the number of mole of ammonium sulfide. But then the question is asked us about how many hydrogen atoms. So you're going to multiply with 8 to get the number of mole of hydrogen. Because why is 8? Because in the ammonium sulfide there is 8 hydrogen, so that's why we multiply by 8. After we get the number of mole of hydrogen, then you can multiply the Avogadro constant, then you will get the number of number of hydrogen atom. So the answer is D. Question number 4. Both ions have same. So option A, number of proton, definitely this answer is wrong because based on the isotope notation, one have 26 proton and then another one have 25 protons. Then next, let's check the number of neutron. So we use neutron number minus the proton number, we'll get 30 for Fe2 plus, and then 55 minus 25, we also get 30 for Mn2 plus. So number of neutron is correct. But then let's check out, because we have one option here is number of neutrons and electron. So maybe we need to check out they have same number of electrons. So 26 protons, but it's 22 plus. So that means proton more than electron 2. So 26 means that number of electron is 24. So same case goes to the manganese ion. There is 25 proton, and then proton is more than electron for 1. So that's why there are 24 electron. So in this case, both Fe2 plus and Mn plus has 24 electrons. So this statement also correct. So the most accurate answer for this question will be they have same number of neutrons and electrons. Question number 5. Calculate the mass of the products if 61.3 grams of KCl3 is consumed in the above reaction. So basically, when the question are given us a chemical equation, we are going to use stoichiometry method to solve this question. So before we can solve this question, when mass is given, we need to determine the number of mole of KClO3 by divide with the molar mass. So after you divide the molar mass, the number of mole of KCl3 is equal to 0.5 mole. So then we need to do the comparison. So in this case, we have to base on the equation. So we need to find out the mass of KCl. So that means we compare 2 mole of KClO3 going to produce 2 mole of KCl. So in this case, we have 0.5 mole of KClO3. So definitely, there will be also produce 0.5 mole of KCl. Then by having the number of mole, we multiply with the molar mass of the KCl. We will get the mass of the KCl is 37.3 gram. So similar method will be going to use to solve the part of the oxygen gas. However, this time, according to the chemical equation, the ratio is 2 to 3. So it means that 2 more KClO3 going to produce 3 more O2. So if we have 0.5 more of KClO3, so definitely it will produce 3 times 0.5 is 1.5. 1.5 divided by 2 is 0.75 more oxygen gas. So same case as well, multiply with the molar mass of the oxygen gas, in this case which is 32 gram per mole. So you will get the answer 24 gram. So the answer will be option B. Question number 6. When you are given one equation and then given the mass, so basically we know this one also is related with the stoichiometry. So 13 gram of zinc react with HCl. So from here we know that the zinc is the limiting reactant. So we are going to compare with limiting reactant. So in this question, they ask us to calculate the volume of the hydrogen gas. So means that we are going to compare zinc with hydrogen gas. And the ratio is 1 to 1, which is quite easier for us. So first, we have to find the number of mole of zinc by using the mass given divide with the molar mass of the zinc. We will able to get the number of mole of zinc. So and then number of mole of zinc will equal to number of mole of hydrogen gas, because it is the ratio is 1 to 1 like we mentioned just now. So but the question is asking us to look for the volume. So with the number of mole of hydrogen gas, if we want to know the volume, we are going to multiply with the molar mass. So the molar volume. So the molar volume at room temperature is 24 liter. Okay, so after we get the liter in the unit of liter, the question mentioned that we need in the unit of ml. So that's why after you get the liter, then you have to multiply in 1000 so that your final answer is in the unit of ml. So press the calculator and you will notice that the final answer is 4800. 56 ml of hydrogen chloride gas dissolved in water to form hydrochloric acid. So we can have the formula HCl. Determine the volume of potassium hydroxide plus KOH of solution 0.2 molar needed to neutralize the acid. So basically after we read this question, we will have the idea this is about stoichiometry question. But this question is different from previous question because this question does not give us the chemical equation. So you are the one who going to write the chemical equation. Hydrochloric acid react with KOH will produce KCl plus H2O. And then this equation is balanced So again, basically, after we have the equation, we're going to find out the number of mole of HCl. So the volume is given, and then molar volume also given at STP. So means that we are going to use volume over molar volume. Then we will get the number of mole for the HCl. Again, because based on the equation, the ratio here is 1 to 1. So that's why number of mole of hydrogen, of HCl also equal to number of mole of KOH. So after we have the number of mole of KOH, and then we relate the number of mole with the concentration. So as we all know, concentration is molarity equal to number of mole of KOH over volume of KOH solution. So we already have the answer for number of mole of KOH, and then we also have molarity of KOH. So from here, we didn't know the volume of KOH, but with now we can calculate it. So the final answer is 12.5 ml. Question number 8. What is the volume of water should be added to 10 cm³ of NaOH 6 molar to produce a solution of NaOH 0.3 molar? So from here we notice that the concentration from 6 molar becomes 0.3 molar. So it means that this is a dilution process. So if this is a dilution process, we are going to use the formula M1V1 equal to M2V2 because the number of mole of the NaOH in the solution is still remain the same even after we adding the water. So in this case, the M1 is 6 molar, the volume is 10, and then the M2 is 0.3, while the volume V2 we have no idea. So basically, when you press the calculator, you will get the V2 is 200 ml. However, the question is asked us how much of the water should be added. So that means initially there is already have 10 ml of 6 molar NaOH. So volume of water added, we are going to use 200 minus 10, which is equal to 190. Question number 9. In a study, it is found that copper abundance is 69.09% for copper 63 and 30.91% for copper 35. If the respective isotopic mass is 62.93 and 64.93 AMU, what is the relative atomic mass of copper? So basically, this question, we are going to solve it using the formula Kimiki. Okay, relative atomic mass. Okay, so but in this case, when we want to use the abundance, yes, for sure they already give us the percentage. While for the mass, we will prefer to use 62.93 instead of the 63. Okay, because 62.93 is more accurate, and then 65 and 64.93, we didn't use 65, but we are going to use 64.93. So press the calculator, you will get the answer 63.55 AMU. Question number 10. The redox reaction between Fe2 plus and MnO4 minus NMO4 minus are given as below. So these are the two half equation. And then this question is asked us calculate the number of mole of NMO4 negative needed to oxidize 1 mole of Fe2 plus. So simple word to say, we are going to combine these two equations, these two half equation. But then we notice that the number of mole for the electron in the first half equation is 1 mole only, while for the second half equation is 5 mole. So means that we are going to multiply this first half equation with 5. Okay, then we are going to cancelling the electron because one is at the right hand side and the other one is at the left hand side. So after we combining these two half equation will be 5 mole of Fe2 plus react with 1 mole of MnO4 negative and 8 mole of H plus, and then we're going to produce 5 mole Fe3 plus and 1 more Mn2 plus with 4 more H2O. So when we look at this overall equation, the ratio is 5 to 1. So if I have 1 more of Fe2 plus, so the number of more of MnO4 that we're going to use will be 0.2 more only. Question 11. The following figure shows the line in the visible region. So when we can see the term visible, we know the series is Balmer series. So if this is the Balmer series, the N final is equal to 2, means that all the electrons will drop to N equal to 2. So which of the following is the transition of the electron? So when you are given a spectrum of the hydrogen atom, first we need to find out the first line of this spectrum. So the first line normally have the biggest gap. So in this case, the first line is this one. So W will be considered as the second line in Balmer series. So if we want to find the second line in Balmer series, so the N final, as we know, it is equal to 2, while the N initial second line we plus the final 2, so which is 2 plus 2, which will be equal to 4. So in this case, the line W will be produced when the electron is dropped from N equal to 4 to N equal to 2. So the answer is D. Question 12. In a line spectrum of emission of hydrogen atom, how many lines can be observed if the electron transit within N equal to 4 to N equal to 1? So basically, maybe we can start with drawing the energy level diagram. N equal to 1, N equal to 2, N equal to 3, and N equal to 4. So when it can form Lyman series, we can have 2 to 1, 3 to 1, and also 4 to 1. Okay, so there is 3 lines can be formed for Lyman series. Next, it will be the Balmer series. So for the Balmer series, it can form from when the electron drop from N equal to 3 to N equal to 2, N equal to 3 to N equal to 2, and then another line will be produced in between N equal to 4 to N equal to 2. So there are only can form 2 lines in Balmer series, and then the last one we can form 1 line only in the Paschen series. So all together here 3 plus 2 plus 1. So totally we can see there are 6 lines in this energy level diagram. Question 13. The electronic configuration with the lowest energy for 7 electrons in a 3D subshell is obtained based on the Aufbau principle. As we know, Aufbau principle allows us to fill up the electrons into the orbital according to the ascending order of energy. What is the wavelength for the 4th line in Balmer series? So as we discussed just now, we know that the N final for Balmer series is equal to 2. So N initial will equal to 4th line is 4, and then Balmer series is 2, so which is equal to 6. Okay, then because of we want to determine the wavelength, so we are going to use the formula 1 over wavelength equal to RH 1 over N1 square minus 1 over N2 square, at where N1 always less than N2. Therefore, in this case, the n final is referred to n1, while the n initial is referred to the n2. So press the calculator, you will get the answer is 410 nanometer. Question 15. The following diagram is the relative energy level for an atom, for hydrogen atom, based on the Bohr's atomic theory. Pick the transition with the shortest wavelength. So as mentioned here, this diagram is related with the energy, and then they want us to look for the wavelength. So from here, we choose the formula delta E equal to hc over lambda. So from this statement, if we want the shortest wavelength, means that the change of the energy should be the greatest. So when we look at here, the greatest energy changes is the P. So the answer is A. Calculate the energy required to excite an electron from n equal to 2 to n equal to 4. So from this statement, we know that n initial is 2 while n final is 4. So if we want to determine the energy, then we are going to use the formula delta E equal to RH 1 over n initial square minus 1 over n final square. So choose the correct Ribet constant and then substitute n initial equal to 2, n final equal to 4. So you will get the answer is 4.09 exponent negative 19 joule. So again, just want to remind that this energy that you calculated is referred to energy that required by an electron only. So if the question asks us to calculate the energy in kilojoule per mole, means that we have to multiply with the Avogadro constant and then divide by 1000 so that it can convert to kilojoule. Question 17. Given the orbital diagram as follows, and then the question asks us to determine the quantum number. So based on this shape of the orbital diagram, we know this one is referred to 3D. So when it is 3D, so means that n equal to 3, L equal to 2, and then the possible answer for m equal to 2 is possible, positive 2, and then spin quantum number possible, s equal to positive half. So the answer is D. Question 18. Which of the following is showing the correct electronic configuration for carbon? So based on the option given here, we know D will be out because according to the alphabet principle, electron need to be filled according to the energy. So 1s is the lowest energy, and then by right it will be able to fill up 2 electrons. But here only have 1 electron, so option D will be out. So then the next one, 2s orbital basically are the similar. Okay, then now means that what make them difference will be 2p. So there are 3 2p orbital, and then all these 3 2p orbital, they have same energy, which we call them as degenerate orbitals. So if they are the degenerate orbital, we are going to follow Hans rule. So according to Hans rule, the electron have to be filled singly. So means that option A will be out as well because the electron is not filled singly. Okay, then the next part of the Hans rule is say that they have to fill in parallel spin. So according to option C, the spin is different. One is downwards and then one is upwards. Means that one is clockwise and then one is anti-clockwise. So the correct answer will be option B. Question 19, we are given electron configuration for copper, which is 1s2 up to 4s1. And then this question asks us to determine the number of electrons in the copper with the azimuthal quantum number L equal to 0. So when L equal to 0, we know that it is referred to the s orbital. So then now we refer to the electron configuration. So for those which are electron in the 1s orbital, we will try to total up then. 1s have 2 electron, 2s have 2 electron, 3s also have 3 electron, while 4s has 1 electron. So means that total we will have 7 electrons with the L equal to 0. Last question, question 20. Orbital with the quantum number n equal to 3, L equal to 2, and m equal to positive 2. So just now we know that when L equal to 0, it is referred to s orbital. So when L equal to 1, it is referred to p orbital. Therefore, when L equal to 2, it is referred to d orbital. So in this case, the answer is Donkey. Thank you for your time in this video. So hope this explanation help you know better in chapter 1 and chapter 2.